the whole essence of binomial expansion is for you to be able to expand things. And in part 1, the only thing that you need is to understand the Pascal's triangle. So for expansions where the power is positive, so the Pascal's triangle only works if the n that we have is a positive integer. So this is the only time the expansion can work. So the Pascal's triangle, you have 1, 1, then you have 1. You add these guys, you get a 2, then you put a 1. You add these guys, you get a 3. You have a 3, you have a 1. You have a 1. Add these guys, you get a 4. Add these guys, you get a 6. You get a 4, you get a 1, and so on and so forth. So this is when n is equal to 1. This is when n is equal to 2. When n is equal to 3. And when n is equal to 4. And so on, right? It goes down like that. So we are saying it works when the power is a positive. That's the only time when it works. It's a positive whole number. It can never be a fraction. It can never be a negative for you to apply Pascal's triangle. So the main idea here of binomial expansion is for you to be able to use simple methods to avoid extra work. Like, you know how you can expand this by multiplying by itself 3 times, right? Now we're saying, using the Pascal's triangle, we can just go on the staircase where n is equal to 3. The staircase is here. These are going to be called the binomial coefficients. So we're saying when n is equal to 3, the coefficients are 1, 3, 3, 1. So I'll write them 1, 3, 3, and 1. That's the first thing that we do. Then the second thing that we need to do is write the first term until it decreases from the power that has been given until we reach 0. So this is going to be like this. This is going to be a 0 there. Then we can do the same for the second term, except it increases. So 2 to the power 0, it starts at 0, then 2, 1, then it goes at 2, 2, then goes at 2, 3. That's what you have. Once you are done arranging that, we can now change and put a plus operation in between the 4 terms that we have. And now we can finish this nicely by simplifying it. This will be x to the power 3. Then this will be plus a 6x squared. Then plus a 12x. Then this is going to be plus an 8 this side. Is there anyone, guys, who is lost here? Is everyone okay on what we've done? Any questions on part 1? Okay, so silence means things are okay. I've just said 3 things here. The Pascal's triangle only works when the power is positive and it's a whole number. Secondly, on arranging the coefficients, the first term always decreases and in terms of the powers, and the second term always increases in terms of the powers all the time. Yeah, so at your convenient time, I'd like you to try this. So obviously you learn something simple, but questions are hard. That's just the way it is. We just want to see whether you can apply. So they'll say expand. I'll put x squared, then minus, I'll put let me say I put y squared, then I put over x. Let me see how you go about this. Then I put a 4 here.
Sorry, can you tell how we got the final answer for the previous example?
Which one? This one here?
Yes.
Okay, so we just simplified by multiplying. Maybe I shouldn't have skipped this stage to show this part here. So what we did is just a simplification of what we had here. So like this is 2 to the power 0 is 1, x to the power 3 is x to the power 3, so 1 times x to the power 3, that's how we came up with x to the power 3. Then this is 2 to the power 1, that's a 2, 2 times 3, that's a 6. Then x to the power 2, that's simply x to the power 2. Here we're having 2 to the power 2 is 4, 4 times 2 times 3, that's how we got the 12, x. Then the last one, this is a 1, so we just have 2 to the power 3, 2 times 2 times 2, that's simply going to give us an 8. That's how we came up with our answer.
Okay, thank you.
Okay, yeah, so having said that, I've given you this task. Now this is a pretty straightforward task. because of people always make mistakes when it comes to negatives and positives. Now I've given you this to see what you will. Let's say I put y there. I'll just put a 3 there to just see how you evaluate things. Yeah. Okay, so I'm moving on to part 2 of binomial. You actually realize today that this is actually a very short topic. So part 2, we learn about factorials. So factorials, just have to do with combinations and arrangement of things. So factorials, if I say n factorial, this simply means n factorial. This will imply n times n minus 1, n minus 1, then n minus 2, and so on and so forth until you have a 1. So if I was to give you 3 factorial, you know to say this will be 3 by 2 by 1. This is going to be a 6. I give you 5 factorial, you just write 5, 4, 3, 2, 1. This is 120. So we're saying if there are 3 things that you are given, the number of ways that you can arrange them is 6 ways. That's what they basically mean. Yeah. So this is like the number of arrangements you can possibly have. Yeah. So there are quick equations that you have to learn under factorials. So there are equations that you have to learn. The first one is the most. So here there are 2 conventional things. 0 factorial is 1, and also 1 factorial is equal to 1. You need to remember this. Whenever you see 0 factorial, just know that it's a 1, and 1 factorial is also equal to a 1. So there are some equations that you must master. The first one is that n choose r is equal to n factorial over n minus r factorial and r factorial, provided r is less than or equal to n. That's a condition. Yeah, so this is sometimes read as n choose r. So if I give you to say 3, or let me say 3 choose 1, meaning how many ways can you choose one thing from 3 things? It's 3 ways, right? Imagine I give you a black pen, a white pen, and a red pen. How many ways can you choose 3 things from here? You can either choose a red one, that's one choice, a white one, that's one choice, or a black one. Those are 3 choices. So even here when you say 3 choose 1, that's the answer you should get. You should get 3. So this will be 3 factorial over 3 minus 1 factorial and 1 factorial. This will be 3 factorial is what, guys? If you're following,
6.
it's a 6 here, so we have a 6 on top. Then down here, this is going to be a 2 factorial. 1 factorial is simply a 1, so this won't change anything. This is going to be 6 over 2. This will just turn out to be 3. That's what you have. That's how we would evaluate this. The condition for this is that this has to be true all the time. You cannot choose this. In short, I cannot give you something like this. 9 choose 10. You cannot choose 10 things from 9 things. That's impossible, right? Yeah, so no wonder that condition must always be true. This case is not possible. Yeah, so if they give you something like this to just test your mind, just say not possible. Yeah, or not solvable, whichever that you feel is okay, because you cannot solve it. Then aside from that equation, we have the second one, which is n choose r is the same as n minus r. They're just telling us to say if I give you 5 choose 3, it's the same answer as 5 choose 2. 5 minus 3 is what? 2, right? So this is the same thing. The number of choosing 3 things from 5 things is the same as the number of choosing 2 things from 5 things. Then we have the next expression, which is n r minus 1. This is equal to n plus 1 and r. So this expression here reads as n choose r plus n choose r minus 1 is equal to n plus 1 choose r, provided the terms that you are looking at on the left, you notice that the top guys are the same, right? 9, 9. Then the guys down differ by 1. Instead of you solving this, then adding with solving this, you can just change the top part to 10, increase it by 1, then get the bigger one between the two values that you have. So the bigger one is your 7. So someone who solves this will get the same answer as someone who solves this. That's what we're basically saying, to say there's a shorter way of writing something that has this type of representation. Then aside from this expression, we can also talk about this guy here, to say, provided you know your n choose n, this is always going to be the same as 2 to the power n. But they rarely ask about this, but you learned it last year. It's also just an identity, yeah, that you have to master. Yeah, so if you look at your 1120 paper, there was a question on this. They were telling us to show. So I think there is here's a question. They were saying show, not prove but show. This is what they were asking for this guy. They want you to show that this plus this is the same as that, provided p and r are positive numbers and p is greater than or equal to r. That's what they're saying. So I'll use that as an example of how we go about our rules. So example, they'll say show is equal to p plus 1 and r. This is what you have. So now whenever they say show, we have to use numbers according to the definition given. So we're going to let p be equal to any number that you want. You give yourself small numbers because you're in the exam, you don't have a calculator, right? So I'll give us 5. Then I'll say r be equal to, let's say something, let's say a 3. Yeah, so we're saying if you replace here, this is going to be 5, choose r. Our r is, this is a 3, plus this is going to be a 5. That's going to be a 2, because 3 minus 1, right? Wherever there's r, I put a 3, so 3 minus 1, that's a 2. Then this other side, we are having a 6. Then choose 3. That's what you have. So now I want to check whether the left is going to be the same as the right. The left is 5, choose 3. 5, choose 2. If you solve not over, but just a normal way, sorry. So just like that. Then this is going to be 5 factorial over 2 factorial and 3 factorial plus 5 factorial, 3 factorial and 2 factorial. This is going to give us a 4 by 3, 5 by 4 by 3 factorial. Then you have 2 by 3 factorial. Then you have 5, 4 and 3 factorial. Then this is 3 factorial, and then 2 factorial is 2. So now we can cancel the 3 factorials on the denominator and the numerator. This is going to be a 2, that will give us a 10. 1, that's going to be a 2, it also give us a 10. This is going to give us a 20. So that's the left hand side that we've gotten. It's a 20. Then we're now here on the right hand side, 6, choose 3. So this is the same as a 6 factorial over 3 factorial and 3 factorial. This is going to be 6 by 5 by 4 by 3 factorial. 1 factorial, we know it's a 6, then we're having another factorial there. We cancel this. 6 cancels as well. This is simply going to give us a 20. You notice that the left hand side is equal to the right hand side, right? So this is when we conclude to say hence shown. This is basically what you have. So here, I'm just trying to show you that it's not all the time that you have to expand. If I was to give you to say 100 factorial, 100 factorial divided by 98 factorial, you're able to see that 98 is found in 100. So it's going to be 100 times 99, then times 98, until we reach the guy which is down. This is 98 factorial. Everything goes here. This will just be 9900. That's basically what we were saying. Any questions, guys, here? Messi, this making sense? Muila, is this okay?
Yes, it is.
Okay. So we can go to the next part. So this was just on the factorials part. Yeah, then the next part now is the one that is very interesting and gives people a lot of hell, which is part 3. But if you understand this, then you'll be cool with the whole topic, literally. So here we're going to have things that we're going to talk about in terms of how to get them and also what they mean. So the first thing is the nth term. You can find any term on an expansion without you actually expanding your expression. That's what we call the nth term. Then number 2, we can get it using this formula, n minus r, then b r. This is basically what we have. Yeah, so if I was to give us to say, imagine this. I want you to imagine, let's say there's this, let's say 3. This will be x3, this will be plus 3x squared plus 3x, then plus a 1. Right? So if we think about this and expressing this, expanding it, I mean using the Pascal's triangle, you get something like that. So now if we have this particular case here, I want you to pretend that we can't see. I want us to pretend as if we can't see this expansion that we've done here. Yeah, so I want you to pretend as if you can't see that. So I'll ask us question based on this. They'll say, the first one, I'll ask us to say find I'll say the third term. That's the first thing I'll say. Number 2, find the term with x to the power. So in the expression, that's a 3, that's x to the power 2. That's what you have. Then number 3, the term independent of x. I know most people hate this, but we need it. So the term independent of x. So these are the 3 common questions that you have to get familiar with. Yeah, so we're going to have the first one. They're saying find the third term. So when the term has been given, I want you to listen closely, guys. When the term has been spotted, has been given like this is the third term. So if it's a third term, meaning you replace it here where there's the nth term to get the r. So we're going to say part 1, we're going to have 3, that's a third term, r plus 1. So meaning r is just going to be equal to 2, right? That's going to be the value of r. So your r now can be used in the second equation. So your second equation now is going to be, this is going to be, our power there is a 3. Yeah, then our r that we found is this. This was our n choose r. Then the first term that we have is simply from the expansion, from the question itself, it's x. So that's what we are having. Three minus that, then we are having the second term, which is supposed to be a 1. This is raised to the power 2. Then 3 choose 2. We can get it the long way. Just get 1 factorial and 2 factorial. This is 3, 1. This is x this side. This will be a 3. Then you have x Okay, so you're having this is a 1. Sorry guys, sorry. This is a 1 here. This is a 1. Okay. This is a 1, so it just disappears or something. Yeah, so this is what I'm getting to be my third term. So if we go back on our question that we were pretending, what's the third term? You notice the third term is exactly the same thing that we were from getting. So this is what we do when we're looking for a term without expansion. So that's what we basically have. We use this formula. You get your R first, then now you replace it in this formula, then you get the term that you want. Yeah, so this is basically the first thing that you have to know on part 3. Before we go anywhere, guys, is there anyone who is lost? Because things are going to be, we're going to be assuming that you understand all the previous content. Is there anyone who is lost here? Leandro, is this okay?
Yes, that's okay.
Okay, so now the difference between question 1 and question 2 is that question 2, they've given you something attached to this term that we're looking for. They're saying find the term that has x to the power 2. So they already know to say whatsoever you calculate needs to have x to the power 2 with itself. So we'll come here and use our formula. This is our part B. We'll say n choose r, a, n minus r, then b to the power r, equate it to the thing that has been given, which is a 2. This is just a 3. R has it been given, or we're looking for it, right? That's the guy we're looking for. Yes, it was not given, and there's no information that can help us to get it. So that's what we're looking for. This is simply x, 3, that. Then you have 1 to the power r. This is equal to x. This, by the time we're done solving this, x must have a power of 2. So this side is simply, you equate the things that have x alone. What has x on the left hand side? The only thing that has x is this part. That's what we're going to get. Then here we're having x squared. This is equal to x squared. So because the bases are the same, we can just equate the powers, right? We can say 3 minus r is equal to 2. Then negative r is equal to 2 minus 3. Negative r is equal to negative 1. R is equal to a 1. So if r is 1, meaning the nth term is what? R plus 1, right? So r plus 1, this is going to give us this part. So I was just saying it's a second term. It's a term that has this guy here. And for sure, if you go back, you notice that it's a second term in our expansion. This guy, this guy here. Yeah, this is what the whole essence or the whole difference between these two guys look like. Then the last one, they're saying the term independent of x. So this means the term which doesn't have x, right, in the expansion. So to get it, always think about x to the power 0, because if I put a, x to the power 0, the answer is just the same thing as what? A. Right? This is what we have. So now we're going to say, this whole thing, 3r, the first term is 3 minus r, then this is 1 to the power r, equate it to this part. Get the parts that have x as well, just x, this part and this part. This is x, 3 minus r is equal to x to the power 0. This, you can just equate this, so r is equal to a 3. So if r is 3, the nth term is equal to 3 plus 1, which is just going to be the fourth term. Okay, any questions, guys? Here, are you okay with how we've gotten the fourth term? Because if you go back, I mean, you scroll on the answer that we said, we pretend as if we don't have it. Look at the last term. It's the only term that is independent of x, and it's alone. This is what you are getting. Yeah. Any questions, guys, up to this point? So are you okay with getting there's a question here, you can just copy this. Let me just, there's a term independent of x that, yeah, this guy here is a very good question. They were saying, here, they're just saying, find the term independent of x. So you can just copy this guy. Yeah, then show me what you're going to work out, then I'll correct you. But the key thing that you have to remember is that whenever you're dealing with fractions, don't forget to put powers on them as well. And you only consider on the things that have x. That's basically what we what we do to make it a bit easier. Are there questions here, guys? Is there anyone who has any question, or we can proceed? Lulu, is this okay?
This is just alright.
Okay, so if this is alright, I'll go to the last part, which is also always there in papers, and there was a question in both. So I don't know if you sat down and compared the 1100 and 1120 papers. They have similar things at some point, but the difference wasn't that, you know, that significant. Yeah, so I think they were in a hurry or something, I don't know, but the papers are almost alike. Yeah, so we are having part 4. Part 4, we are saying there is an expansion. So let me write this. There is an expansion that we do whenever the power is a negative or it's a fraction. So this means the number is either a negative, the power is negative, or it's a fraction. That's when we only apply this formula. And it also only works if the first term is a 1. And if the first term is not a 1, but the power is either negative or a fraction, you have to always make your first term to be a 1 before you apply the following formula, which states that the expansion is going to be nax. This is ax, this part. Then we are having plus n minus 1, 2 factorial. This is ax squared. Then we are having n minus 1. Then you have n minus 2 over 3 factorial. This is going to be ax squared. This is cubed, right? That's what you get. So this is what you get. Then why are we ending here? Because you guys will always be told to end up to the 4th term, or to the term that has x to the power 3. Yeah, that's the furthest you guys can go, because it's a series, it's non-terminating. Another thing you need to know is the valid region where your expansion is found. This is always modulus of whatsoever is here. Put it there, ax, then less than 1. This here is how you get the valid region. Yeah, so here, if you notice, there's a pattern. The pattern is that there's ax here, ax to the power 2, ax to the power 3. Here there's n, then there's n and n minus 1, and n minus 2. So there is a formatting on how you can easily remember the whole formula. This is basically what you have. And if you look at the questions you guys had in both papers, all the questions were just straightforward. So by straightforward, I mean the first term is a 1. So let me give you this guy here. As an example, for instance, so I want to use something as an example. So like this part here, they're just saying expand 1 plus 3x to the power negative 2 in the ascending powers of x up to and including the term in x to the power 3. So this is going to be a bit straightforward as well, because the guy at the beginning is already 1. So we have 1 plus 3x. So we have 1 plus 3x. Okay. Then this is raised to the power negative 2. Then they want you to expand up to this. So we're just saying this can follow the expression to say this is going to be negative 2. Then you have 3x. Then you have plus negative 2. Negative 2 minus 1. This is 2 factorial. 3x squared plus 3. Then you're having this. This is 3 factorial. Then we're having 3x to the power 2. So this is basically what we have whenever we're trying to expand this guy. So this is what you get. Yeah, then you can simplify it. You get 1 minus 6x. And then this will be negative, and this is going to be negative, so it will be positive. This is a 2, and the 2 can go away, so just having this part. This is negative 3, and which one? 3x squared. Okay, so here I'm just trying to simplify this. It becomes that. Then the negative doesn't go away here, so we have this. Then this guy here is going to be negative 3, negative 3. Then this is going to be negative 4 and 3x. Then down here you just have this part here, because 3 factorial is simply 6, right? So this is what you get. Now we start expanding this. This is equal to 1 minus 6x. This is 3, then this is 9x squared. Okay, so this is okay, this is okay. Then this is simply a 6 there, so 6 and a 12, that's going to be a 3. This is going to be a negative 9. Then you have this is a 3 here, so it'll be 27x to the power 3. Then here now we can try to just compute this. Is going to give us a 27x squared. This guy here, so we're having this. So let me just check this out. What is 9 times 27? Anyone who's calculated it? What is 9 times 27?
243.
246. So we are having
243.
or 243. X3 then plus. This is what you have. So if this is what we're getting as the expansion, we can even state the region of validity region to be, we just say it's going to be AX, which is what? AX is simply 3x. So I just say valid region will be 3x less than 1. You can take the 3 outside, then you can divide by 3, so modulus of x is less than 1 over 3. So this is simply the valid region that we have. So I just explained. I'll take it back on the formula so that you look at the formula, because that's the only key thing here. Just you mastering the formula and applying it. Yeah, so okay, this is basically it. And if it's not a you make it an A. Let me give you a situation. Let's say we have 16x. This is this. Then you have 1 over 2. This is going to be 4, 1 plus 4x. Then this is 1 over 4, 1 over 2 I mean, because here there is a 2. So that here now you're going to have, this is going to be a square root of 4, which is a 2, and this is now the expansion. So now you can just do the expansion, then multiply every term by 2. Yeah, that's basically how you get it. Valid region will be modulus. After this guy is a 1, that's when you get the valid region. So valid region of this case will just be 4x, then less than a 1. Is there a question, guys? Musutu, are you getting what I'm saying, or I'm very fast? Is this okay?
Yeah, fine, sir. But can you please, can you go back to the previous screen?
Okay. Let me take it back.
No, a bit down. A bit down. So, sir, I wanted to ask, the 6 cancels with, where did the 6 go? I'm a bit confused.
Oh, the 6, this 6 which is here.
Yes, where did it go?
Oh, okay. So how I did it is that this was let me just do this a bit. Okay, so there was this was okay. You are okay up to this stage, right?
Yeah.
So now I was just multiplying. So I multiplied 4, -3 by -4. That's going to be a 12, right?
Yeah.
Yeah, so I think I actually did make a mistake. Thank you for correcting us. I did 6 into the answer that we got here. It's supposed to give us a 2, right? Then now the -3 times the 2. So this is going to be a 6. That's going to be a 6 here. Then a 6 now by 27. We get your answer here, your correct answer this side. Yeah, you've seen what the 6 has gone, right?
Yes, sir.
Yeah, so we're just trying to simplify our working here. So any questions, guys, here? So here I'm just trying to give an illustration. When the first term is not a 1 and you're trying to get the region of validity, you can only get it when the first term is a 1, this part. Not here when you're saying this is not a 1 and they're asking for that. You have to always divide until you make this guy to be a 1. Yeah, so this is basically what you have on binomial, unless if there are other questions, but this is basically what covers it all. So whenever it comes to whenever they say the term independent of x, meaning they're looking for the term that has x to the power 0. Just be having this in mind, then everything will be okay. Yeah, so hopefully there are no questions, or if there are any concerns or you encounter any questions, please feel free to ask. But this is the whole summary that you need on binomial. Any questions, guys? Messi, do you have any questions?
No, sir. Yeah.
Okay, so at least we're done with binomial. Now you can look at the paper for last year. Try to attempt every question on binomial. Then let me know if it's proving to be still challenging. Yeah, but you see all the solutions that I'll upload, the whole paper for everything. So you just be comparing with your working and stuff like that. But this is where the binomial thing ends from. So we'll end our session for math here. Let me communicate with those that are taking chem.